Have you ever watched a road roller slowly move across a newly paved road and wondered how the giant machine can turn rough asphalt into a perfectly smooth surface? At first glance, it looks simple. A heavy machine drives back and forth until the road looks flat. But in reality, a road roller is one of the most important machines in modern construction. Hidden inside its massive steel drum is a clever engineering system that uses weight, vibration, and physics to create roads strong enough to support millions of vehicles. Without road rollers, highways would crack, sink, and develop potholes much sooner. Every smooth road you drive on today depends on this powerful machine. So how does a road roller really work? And what is happening inside that giant drum as it moves across the ground? Let's find out. The primary job of a road roller is to compact materials. Compaction means squeezing particles closer together and removing the air spaces between them. Whether workers are building a highway, airport runway, parking lot, or construction site, the surface underneath must be compacted before it can support heavy loads. Fresh asphalt, gravel, and soil all contain tiny pockets of air. If those air pockets remain, the surface becomes weak and unstable. Over time, vehicles passing over the road can cause it to crack, sink, or develop potholes. The road roller solves this problem by compressing the material and forcing the particles closer together. The result is a stronger, denser, and more durable surface. Many people assume a road roller works simply because it is heavy. Weight is certainly important. A typical road roller can weigh anywhere from 10 to more than 20 tons. Some large rollers used on major construction projects are even heavier. That enormous weight creates a tremendous amount of downward force. However, weight alone isn't enough. Imagine filling a bucket with sand. If you simply press down on the sand with your hand, it becomes slightly denser. But if you shake the bucket while pressing down, the grains settle much more tightly. Road rollers use exactly the same principle. This is where vibration becomes important. Inside the steel drum of most modern road rollers is a rotating eccentric weight. An eccentric weight is simply a heavy object mounted off-center. As it spins, the weight creates powerful vibrations. Think about a washing machine when all the clothes gather on one side. The machine starts shaking because the weight is unevenly distributed. Road rollers intentionally create this effect. When the eccentric weight spins thousands of times per minute, it causes the entire drum to vibrate. Those vibrations travel through the asphalt, gravel, or soil beneath the machine. The particles begin moving, rearranging themselves, and settling into tighter positions. As the particles move closer together, air pockets disappear and the material becomes much denser. This is why vibratory rollers are far more effective than machines that rely on weight alone. To understand this process better, let's look at what happens during road construction. After fresh asphalt is laid, it may look smooth, but it still contains countless tiny air spaces. The road roller begins moving across the surface. As it rolls forward, the drum applies tremendous pressure while simultaneously vibrating. The vibrations cause aggregate stones and asphalt particles to shift and settle. Air pockets collapse. The material becomes denser. Each pass of the roller increases compaction. Construction crews often make multiple passes over the same area to achieve the required density. Engineers carefully monitor this process because proper compaction is critical. Too little compaction creates a weak road. Too much compaction can damage the asphalt structure. Finding the perfect balance is one of the most important parts of road construction. Another feature many people notice is the enormous size of the drum. The drum is designed to spread force evenly across a large area. If all that force were concentrated into a small contact point, the surface could become uneven. Instead, the wide drum distributes pressure uniformly. As the roller moves forward, operators overlap each pass slightly to ensure every section of the road receives the same amount of compaction. This overlap helps eliminate weak spots and creates a smooth finished surface. Not all road rollers are built the same way. Different construction projects require different types of rollers. The most common type is the smooth drum roller. This is the classic road roller most people recognize. It uses a large steel drum and is commonly used for asphalt paving. Another type is the pad foot roller. Instead of a smooth drum, it has raised knobs attached to the surface. These knobs dig into the soil and are especially effective for compacting clay and other difficult materials. There are also pneumatic rollers. These machines use multiple rubber tires instead of steel drums. The tires provide a different type of pressure and are often used to help seal asphalt surfaces. Double drum rollers feature drums at both the front and rear. These machines provide highly uniform compaction and are frequently used on highways and large paving projects. Each type of roller is designed for specific conditions and materials. One of the most impressive aspects of a road roller is how deeply its vibrations can penetrate. Although the drum only touches the surface, the effects can reach several feet below ground. The exact depth depends on factors such as roller weight, vibration frequency, soil type, moisture content, and drum size. Engineers carefully choose the appropriate roller for each project to ensure compaction reaches the required depth. If deeper layers remain loose, the entire structure can eventually fail. This is why compaction is about much more than just making the top layer look smooth. A strong road starts from the layers beneath the surface. Many people have also noticed water being sprayed onto the drum during paving operations. At first glance, it might seem like the water is cooling the drum. In reality, its main purpose is to prevent asphalt from sticking. Fresh asphalt is extremely hot and sticky. Without water, asphalt could cling to the drum and pull material away from the road surface. The water creates a thin barrier that keeps the drum clean and helps produce a smooth finish. Modern road rollers have become much more advanced than the machines used decades ago. Many now include GPS systems, onboard computers, temperature sensors, and compaction monitoring technology. These systems help operators determine exactly where compaction has occurred and whether additional passes are necessary. Some advanced rollers can even estimate compaction levels in real time. This technology improves efficiency, reduces fuel consumption, and helps ensure that roads meet strict engineering standards. One reason road rollers move so slowly is because compaction takes time. Many people assume construction crews could finish faster by driving the machine more quickly. However, moving too fast reduces the effectiveness of compaction. The vibrations need time to travel through the material and allow particles to settle properly. A slower speed ensures maximum compaction and better results. Although it may seem inefficient, moving slowly actually produces stronger roads. The science behind vibration is surprisingly fascinating. When the drum vibrates, particles within the soil or asphalt temporarily overcome friction and begin moving. As they move, gravity and pressure encourage them to settle into tighter positions. Think about shaking a box filled with rocks. After a few shakes, the rocks settle and occupy less space. The same thing happens beneath a road roller. This simple principle allows engineers to create surfaces capable of supporting enormous loads for many years. What happens if a road isn't compacted properly? The consequences can be expensive. Poor compaction often leads to cracks, potholes, rutting, uneven surfaces, and water damage. Water can seep into small gaps and weaken the structure beneath the road. In cold climates, freezing and thawing can make the problem even worse. A road designed to last 20 years might begin showing signs of failure after only a few years if compaction is inadequate. This is why road rollers are among the most important machines on any construction project. To appreciate the power of these machines, consider this. Large vibratory rollers can generate forces equivalent to tens of thousands of pounds. Every second, the spinning eccentric weight inside the drum creates powerful vibrations that travel deep into the ground. The machine may appear slow and calm from the outside, but beneath the surface it is transferring an enormous amount of energy. That energy transforms loose soil, gravel, and asphalt into a strong foundation capable of supporting countless vehicles every day. In many ways, the road roller is the unsung hero of modern transportation. Drivers rarely notice it after construction is complete. Yet every smooth highway, airport runway, parking lot, and city street depends on the work this machine performs. Without proper compaction, modern infrastructure simply wouldn't last. So the next time you see a road roller moving back and forth at a construction site, you'll know that much more is happening than meets the eye. Inside that giant steel drum, a rotating off-center weight creates powerful vibrations. Combined with the machine's enormous weight, those vibrations remove air pockets, compact materials, and create the strong, durable surfaces we rely on every day. What looks like a slow-moving machine is actually one of the most important engineering tools ever developed, helping build the roads that keep the world moving.